Behind every legend lies a reason. This is Myth and Motive.
Hello, ladies and gentlemen. In the vast ocean, where light cannot reach and pressure is enough to crush steel, exists a mysterious and incredibly deep world. The Mariana Trench is not only the deepest place on Earth, but also a gateway to the unknown aspects of our planet. At depths exceeding 10,000 meters, the Mariana Trench tells miraculous stories of how Earth formed, about strange creatures silently surviving, and even the footprints of humanity in a journey of exploration. Let's peer through the lens of wonder and today. The Mariana Trench, or Mariana Trench, is one of the most unique natural wonders on Earth, located at the bottom of the ocean in the western Pacific, near the Mariana Islands. A chain of volcanic islands under U.S. territory. It holds the record for depth compared to any other area on the planet, with its deepest known point being Challenger Deep, reaching about 10,984 meters below sea level. To visualize, if Mount Everest at 8,849 meters were placed in this trench, it would still be nearly 2 kilometers below the water's surface. This makes the Mariana Trench one of the most remote and inaccessible places on Earth. The Mariana Trench is a vivid testament to the constant movement of Earth's crust, formed over millions of years through plate tectonics. This trench is where the Pacific Plate, one of the largest tectonic plates on the planet, subducts beneath the smaller Philippine Plate, creating a subduction zone. The deep subduction zone, where when two tectonic plates meet, the heavier one, usually the oceanic crust, is pushed down into the mantle below, while the lighter plate remains on the surface. This process not only formed the Mariana Trench, but also continuously reshapes the underwater landscape. The special feature of the Mariana Trench lies in its geological structure. It is not just a simple crack, but a complex system of deformation zones, where the oceanic crust is compressed, folding, and forms cracks or underwater ridges. Beneath the trench floor, the Pacific Plate continues to sink deep into the mantle, heating and partially melting, causing frequent volcanic and earthquake activity. These submarine volcanic activities have partly shaped the Mariana Islands, the chain of volcanoes on the ocean surface near the trench. Additionally, the crustal structure in the Mariana Trench is old. The oceanic crust here is older and denser than in many other places, as it formed over 150 million years ago. This makes it more prone to subducting beneath the Philippine Plate, creating significant height differences and contributing to the trench's deepening over time. Moreover, the Mariana Trench is part of the global geological cycle, where tectonic plates sink into Earth's interior and reintegrate into the mantle. This cycle plays a crucial role in maintaining the balance of the planet's crust. Thanks to this mechanism, the Mariana Trench becomes a symbol not only of constant motion but also of Earth's endless regeneration and transformation over hundreds of millions of years. An interesting fact about the Mariana Trench is that the environmental conditions here are so extreme that it's hard to believe life can exist. At this depth, water pressure increases to 1,086 bars, equivalent to the weight of a jet plane on a fingertip. To cope, organisms here have developed special cellular structures with reinforced cell membranes and pressure-resistant proteins. Water temperature near the trench bottom ranges from 1 to 4 degrees Celsius, and there's absolutely no sunlight. However, in areas near hydrothermal vents, temperatures can suddenly rise to over 100 degrees Celsius. This extreme temperature difference forces organisms to develop unique temperature regulation mechanisms. For example, tube worms living near hydrothermal vents rely on symbiotic bacteria to utilize energy from chemical compounds in the hot water. Some bacteria and unicellular organisms use flexible cell membranes with special structures to resist crushing pressure. Additionally, molecules in our bodies, such as proteins and enzymes, have more stable structures allowing them to function effectively in high-pressure environments. These molecules are called piezolites, which help maintain protein stability under harsh conditions and are subjects of study in biomedical fields. With no sunlight reaching this depth, organisms in the Mariana Trench cannot rely on photosynthesis for energy. Instead, they survive through chemosynthetic processes. The chemosynthetic ecosystem here often centers around hydrothermal vents. where temperatures can be higher than the surroundings and chemical compounds like hydrogen, sulfide, and methane are released from the Earth's interior. Despite the pitch black darkness of the Mariana Trench, this unique ecosystem sustains life. The organisms here display diversity in shape, size, and survival strategies. One of the prominent creatures in this ecosystem is the giant tube worm Rhytkia pagitilla, up to 2.4 meters long, living near hydrothermal vents. This worm has no mouth or gut and lives through a symbiotic relationship with chemosynthetic bacteria in its body. These bacteria convert hydrogen, sulfide, into energy, nourishing the worm and other surrounding organisms. Next is the Mariana snailfish. This fish is recorded as the deepest living fish ever discovered, and that's over 8,000 meters. Despite living under extremely high pressure, this fish has a soft body structure, helping it endure the harsh environment. Their bodies contain a lot of fat and special biological compounds, helping maintain cell structure under extreme pressure. Surprisingly, this fish does not hunt aggressively but uses a strategy of waiting for food to fall from the waters above. Another unique creature is the giant amphipod. Amphipods are a group of small crustaceans commonly found in both shallow and deep waters. However, in the Mariana Trench, they grow to gigantic sizes, up to over 30 centimeters long, much larger than their shallow water relatives. This size can be explained by the phenomenon of deep-sea gigantism, a biological trend common in deep-sea organisms where metabolic rates are slow and lifespans are longer. The iconic figure of the Mariana Trench is the blind shrimp. Blind shrimp live near hydrothermal vents, with sharp special senses to detect temperature and chemicals, helping locate energy sources in complete dark. Additionally, isophilic bacteria also play an important role in the trench's ecosystem. They are not only the foundation of the food chain but also participate in chemosynthesis at hydrothermal vents. These giant bacteria live in symbiosis with species like tube worms, providing chemical energy to nourish the entire ecosystem. This is a remarkable demonstration of how life could develop without relying on sunlight. The organisms here form a closed food chain, where chemosynthetic giant bacteria play the role of energy plants, providing food for tube worms, blind shrimp, and fish. Despite the lack of sunlight, this ecosystem maintains balance, demonstrating the diversity and self-regulating ability of nature. The organisms here make extremely significant contributions to scientific research. The biological compounds produced by giant bacteria in the Mariana Trench have potential applications in medicine, particularly in developing antibiotics and anti-cancer drugs. Studying the body structures of high-pressure resistant organisms can help develop pressure-resistant materials in submarine technology. S. Europa or Saturn. Exploring the Mariana Trench is not only a major milestone in science and technology, but also opens up opportunities to access a completely different world, where immense pressure, perpetual darkness, and frigid temperatures dominate. The history of exploring the Mariana Trench spans over a century, but even with modern technological advances, only a very small part of it has been studied. Each expedition brings new discoveries and challenges the limits of human understanding. The journey to explore the Mariana Trench began in the 19th century when humans had only a partial conception of the ocean's true depth. In 1875, the HMS Challenger conducted a comprehensive ocean survey and first recorded the astonishing depth of over 8,000 meters in this trench. However, the measurement equipment at that time was limited, making accurate depth determination a major challenge. By 1951, the HMS Challenger 2 used more advanced sonar equipment and first recorded the record depth at Challenger Deep, confirming it as the deepest point on Earth. Since then, the Mariana Trench has become an important target for scientists, attracting interest not only from researchers but also from the international community. One of the major breakthroughs in exploring the Mariana Trench occurred on January 23, 1960, when explorers Jacques Piccard and Don Walsh in the bathyscaphe Trieste reached Challenger Deep. This was an extraordinary feat because submarine technology at that time was very primitive, and the pressure at depths over 10,000 was a huge challenge. Trieste, with a cavitate of steel and big glass, withstood the pressure equivalent to thousands of tons of water. The journey lasting over 5 hours proved that humans can overcome seemingly impossible limits to reach the most remote places on the planet. During this dive, Picard and Walsh reported observing living organisms, including a flatfish resembling a flounder. However, this discovery later sparked controversy because conditions at Challenger Deep seemed unsuitable for such fish life. Nevertheless, the Trieste expedition opened a new era in deep-sea research. In 2012, renowned director James Cameron made history by becoming the first person to make a solo dive to Challenger Deep.
Using the deep-sea Challenger submersible, Cameron spent over 3 hours at the bottom of the trench filming, collecting samples, and studying the ecosystem.
Unlike previous expeditions, Cameron brought advanced imaging technology, providing the first high-quality images of the Mariana Trench floor. He described the place as an underwater desert, with muddy terrain and eerily silent space.
Of course, exploring the Mariana Trench is a challenging task that requires a combination of advanced technology and innovative techniques.
The pressure at Challenger Deep reaches over 1,000 times atmospheric pressure, capable of destroying most conventional materials.
Therefore, submersibles used to study the trench must be specially manufactured.
Modern submersibles like Deep-Sea Challenger or Triton 36,000
are made from titanium or ultra-strong alloys capable of withstanding immense pressure.
Autonomous robots like Nerus and Kaiko have been deployed to explore areas inaccessible to humans.
They are equipped with cameras, sampling devices, and sensors to collect data from the seabed environment.
Due to the absence of GPS
Signals at the ocean floor, submersibles must use acoustic positioning systems to determine location. Because of these expensive technologies, each expedition requires millions of US dollars in equipment and operational investment.
However, the immense pressure and harsh conditions mean any small error could lead to disaster. Current submersibles can typically only operate for short periods due to energy limitations and human endurance.
Therefore, exploring the Mariana Trench still faces many challenges.
Like many other places, the Mariana Trench holds many mysteries and incredible stories. Some reports from recent expeditions indicate that researchers have detected strange lights flashing in the bottom area of the Mariana Trench. These lights do not come from artificial devices and could be the result of natural chemical reactions or unidentified bioluminescent organisms.
Although there's no concrete evidence, these phenomena have sparked many hypotheses about the existence of special life forms or unique geological phenomena. Scientists recorded a series of strange sounds, lasting from 3.5 to 3.8 seconds, emanated from the depth of the Mariana Trench, called the West Pacific Biaphone.
This sound has a frequency unlike any known marine animal sound. Hypotheses suggest the sound could be emitted by beaked whales, but the exact origin remains a mystery.
Beyond that, the Mariana Trench has long been the center of conspiracy theories due to speculation about giant creatures like sea monsters or the ancient megalodon shark.
Although there's no verified scientific evidence, these stories are often woven from blurry images or informal reports from fishermen and explorers.
Despite requiring significant time, effort, and money, the results scientists obtain are extremely worthwhile.
One of the greatest significances of the Mariana Trench is its ability to expand understanding of life in extreme conditions.
From a geological perspective, the Mariana Trench is an ideal place to study plate tectonic activity and Earth's orbits. This is one of the most active subduction zones, where oceanic crust explores the continental crust, causing phenomena like earthquakes, volcanoes, and seamount formation.
Studying this trench helps scientists better understand how geological energy is released while predicting seismic risks. This is particularly important for areas located on the Pacific Ring of Fire, which have high population density and are frequently affected by earthquakes and tsunamis.
Pressure-tolerant microbes, mesophylae in this trench, have the ability to convert chemical substances from hydrothermal vents into energy.
Without needing sunlight,
this strongly emphasizes the importance of searching for extraterrestrial life, especially on celestial bodies with subsurface oceans like Europa's
moon, or Enceladus, Saturn. For example, Enzymes from pressure-tolerant microbes can be used in pharmaceutical production or bioremediation in harsh environments. Instead, the Mariana Trench plays an important role in the carbon cycle, an essential part of global climate balance. Here, carbon particles from the ocean surface sink and become buried at the trench bottom, where they can be isolated for millions of years. This process helps reduce atmospheric carbon, slowing down climate change.
However, the mechanism of carbon transport to the deep ocean layers is not yet fully understood.
Scientists believe that more detailed research on how carbon is stored in ocean trenches could help humans develop more effective greenhouse gas reduction strategies. This is particularly important in the context of Earth facing serious climate change issues.
Although located at depths over 10,000 meters below the ocean surface, it was once considered one of the most isolated and pristine places on Earth.
Recent studies have revealed a concerning reality. Pollution from human activities has reached even these deepest regions.
This not only warns about the widespread extent of pollution, but also raises major questions about global environmental protection responsibilities. One of the most notable discoveries is the presence of microplastics in water samples and organisms from the Mariana Trench.
Microplastics, plastic fragments smaller than 5 millimeters, were found in amphipods living in the Challenger Deep. These plastic particles originate from decomposed plastic waste at the ocean surface and then sink to the bottom through ocean currents and sedimentation processes.
In addition to microplastics, scientists also discovered the presence of persistent organic pollutants.
Persistent organic pollutants, abbreviated as POPs, such as PCBs, polychlorinated biphenyls, and PBDEs, polybrominated diphenyl ethers.
These substances were once used in industry and manufacturing, and although banned in many countries, they persist in the environment for decades due to their slow degradation.
In the Mariana Trench, PCBs have been found in organisms, showing that even ecosystems at extreme depths are not free from human impact.
Pollution in the Mariana Trench originates from surface activities, including plastic waste discharge, industrial chemicals, and other toxic substances.
Ocean currents and circulation play a role in transporting these substances to deep layers,
along with heavier-than-water substances sinking through the marine snow sedimentation process.
Also contributing to pollution entering the deep-sea ecosystem. Pollution in the Mariana Trench is not just about the physical presence of waste, but also affects the entire ecosystem.
Organisms here, already adapted to harsh living conditions, now face the accumulation of toxins in their bodies.
For example, amphipods, important crustaceans in the food chain, when absorbing PCBs or microplastics, indirectly affect higher-level predators.
Furthermore, the presence of plastics and chemicals also changes the physical and chemical properties of the deep-sea environment,
negatively affecting the stability and natural balance of the ecosystem here. Not only a natural wonder, the Mariana Trench is also a symbol of mystery and challenge. It has attracted the attention of scientists, explorers, and passionate discovery enthusiasts.
Although there have been many eyes to the trench bottom, most of this area remains incompletely surveyed,
making the Mariana Trench one of the last places on Earth that humans have not truly fully conquered.
Therefore, this trench not only serves as a special geographical symbol,
but also as a scientific treasure that needs continued research and preservation. And today's video ends here. Thank you all for your support. Don't forget to subscribe to the channel so you don't.
If the legend hooked you, subscribe and open the next case.